My screen is visible to everybody?
Yes, sir.
Yes, sir.
Okay. 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 So in the previous lecture, we have started with the root locus method. So this root locus method is the second part in unit number 4, and always the 13 marks question is asked based on this root locus. Okay, so please understood this, which is very simple method and easy to score. Okay, so the only 7-8 steps are there, which are very easy. So what do you mean by root locus? So root locus is a graphical method. It is a graphical method. Okay, and the name itself indicates that root locus method. So in the harvest determinant or in the root array method, we have determined the range of k. So let's say range of k is between 0 to 11.36, where this 11.36 is called as the marginal value. So marginal value means the value of root at this value of k, when k is equal to 11.36. So at this value of k, your roots of characteristic equations are intersecting on imaginary axis. Okay, so when roots of your characteristic equation intersect on imaginary axis, then such value is called as the marginal value of the key. Okay, so therefore, in root locus is nothing but what? Simply the locus of your roots of your characteristic equation is nothing but a root locus, and your root locus always start at k is equal to 0, and it may terminate on the either open loop zeros or either on the infinity. So that we will see how it will be. So root locus always originate at k is equal to 0 at open loop poles. Okay, so therefore this is the actual meaning of root locus. So root locus means whatever is the characteristic equation given to us. Okay, so the locus of your characteristic equation in the S plane is nothing but the root locus. Okay, so let's discuss about the construction rules of root locus. So give the next heading: construction rules. Construction rule for root locus. Okay, so rule number 1: your root locus is always symmetrical about always symmetrical about the real axis. Okay, so why it is symmetrical about real axis? So we know that the roots of the characteristic equation, roots of the characteristic equation, either it could be real, either it could be complex, or either it could be a combination of these. So therefore, your root locus is always symmetrical about the real axis. Okay. Then second rule. First of all, we have to find out how many number of poles and how many number of zeros are present in your transfer function, or in. Okay. So therefore, uh, the open loop transfer function is given to us g of s into h of s. So this value is given to us, and this is called as open loop transfer function. Open loop transfer function of the system. So these values are given to us. So in this open loop transfer function, So let's say any example, say G of S into H of S. So it could be given by say K upon S plus 2 into S plus 4, and here is S plus 1, like this. So here, this is your open loop transfer function given. So here in this case, the 1, 0 is present and two poles are present. So that means here Z is equal to 1 and P is equal to 2. Okay, so this information we can obtain from the open loop transfer function which is given to us. Okay, so here you just note down what is P. P is the number of open loop poles, number of open loop poles in the transfer function, and Z is the number of open loop zeros in the transfer function. Okay, so now there are three possibilities. Okay, so sometimes your P could be greater than 0, or sometimes Z could be greater than P, or sometimes Z is equal to P. So for these three cases we have to analyze our system. Okay, so first case we can consider, we can discuss all the three possibilities when number of poles are greater than number of zeros. Okay, so in this case, we have to find out the number of branches of your root locus. Okay, so therefore, where this capital N indicates the number of root locus branches. Okay, so number of branches of root locus. Okay, so when P greater than Z, so what is the value of N in this case? So in this case, N will be given by N is equal to number of open loop poles of your transfer function. So N is equal to P when P greater than Z. Okay, then your root locus, so always remember that root locus always originate at open loop poles and terminates at open loop 0 if present. If 0 is not present, then it may terminate infinite. Okay, sir, and the point at which your root locus start, so that point is corresponding to always k is equal to 0. So therefore the branches of your root locus, that is n branches, so each branch, so write down here, each branch of root locus, each branch of root locus originate at open loop pole, that is at k is equal to 0, and terminate at, so here is where your branch will going to terminate, and terminate open loop 0 if present. Okay, if not it terminates on infinity. If not, it terminates on infinity. So that means your root locus branch may start at k is equal to 0 and ends at open loop 0 if present. If not, it may terminate on infinity. Okay, so we just find out how many branches are terminating on infinity. So it depends on your number of poles and number of zeros. So यहाँ पर if you take this example, in this example number of poles are 2 and number of zeros are 1. So that means one branch will start at one pole P1. So we have two pole P1, P2, and we have one 0. So one branch will originate at k is equal to 0 at P1 and terminate at Z. But what about second branch? Second branch will be start at P2 at k is equal to 0, but where it can be end, so there is no presence of 0 to terminate it on. So therefore it may terminate on the virtual 0. So it is called as infinity. Okay, so this branch may terminate on infinity like this. So how many number of branches are terminating on infinity? So it will be given by p minus z. So here 2 minus 1, so that is 1. So p minus z branches are always terminating on the infinity. Okay, so therefore you just write down the number of branches, the number of branches terminating, number of branches terminating on infinity is given by p minus z. Okay, so this is all about the first case when p greater than z. Okay, so similarly you can analyze the second thing for z greater than p. So there may be a possibility the number of zeros are greater than number of poles sometimes. Okay, so here in this case we have to find out the number of branches N. So here capital N is equal to total number of zeros in the system when z greater than p. Okay, then here in this case what happened? We know that each branch will start at poles and terminates at 0. But here in this case, as p is less than z, so only one branch will terminate on 0. But other which are starts at infinity and terminates on 0. So therefore, how many branches will start from infinity and ends at 0? So it will be given by z minus p. Okay, so therefore you just write down here in this case. So when z greater than p, each branch starts from pole p and ends at 0. Okay, but as z is greater than p, then z minus p branches never starts at pole. So z minus p branches will always starts at infinity and ends at 0. Okay, so therefore you just write down, but z minus p branches, z minus p branches start at infinity and ends at 0. So both are the exactly opposite cases. So here when p greater than z, each branch will originate at poles and terminates on 0. If 0 not present, then it may terminate on infinity. Here as zeros are greater, so therefore branches will be originate at infinity and terminates on 0. So this is the difference between them. Okay. So this is for z greater than p. These are very rare. Okay. Then the third possibility could be z is equal to p or p is equal to z. So here in this case, the total number of branches will be given by n is equal to p is equal to z. So here in this case, all branches will be originating at poles and terminating at zeros, because here in this case p is equal to 3, so z is equal to also 3. So all the branches will be originate at poles and terminates at 0. So therefore no one branch will originate at poles and terminating on infinity, or no one branch will originate at infinity and terminating on zeros. Okay, so here is the balanced case. So therefore you just write down the explanation for this. Okay, and always remember that how is your branch direction. So branch direction is always from how your root locus branch direction. So root locus branch direction always from poles to 0. Okay, so branch direction always remain from open loop pole to open loop 0 to open loop 0. Okay, so here in this case, when n is equal to p is equal to z, in this case, okay, so as p is equal to z, so which is equal to n, so therefore separate branch will start at pole and terminates on 0. Okay, so no branch will start or terminate at infinity. No branch will start or terminate on infinity in this case, because here number of poles is equal to number of 0. So this is the first step. So in the first step, we have to find out how many number of poles and how many number of zeros are present. So depending upon this, three possibilities will get. According to that, we just decide the number of branches and how many branches are terminating on infinity or how many branches are terminating on 0. This information we can easily obtain. So this is your step number 1 while constructing a root locus. So I request you all, please note down this. So this is the very first step of your root locus construction. So if you have any doubt, please ask. So whenever you are taking the example, again it will be clear to you. So always remember that when we get the information about P and Z, we determine the expression for capital N, and once you get N, how branches will be terminating on infinity or terminating on 0. So those information we can obtain from this three condition. Okay, so this is your step number 1, 2. Okay, then we go for next step. So please note down this. So write down step number 3. Existence of root locus. Existence of root locus on the real axis. Existence of root locus on real axis. Okay, so how to determine where existence of root locus on real axis or not? Okay, so for that purpose we just take one example. So you just note down here. Here we have to find out simply P plus Z. So when P plus Z on a particular section is odd, then it is a part of root locus. We just write down it is a part of root locus. And when P plus Z on a particular section is even, then it is a part of non-root locus. So you just remember this rule. Okay, just take the example. Let's say this is sigma and this is j omega axis. This is your S plane. And let's say one pole is located at 0. One pole is located at -4. Okay, and this will be your minus infinity. Okay, so here this is the example, and we have to find the existence of root locus on real axis. So while considering this P plus Z, do not consider the complex conjugate poles. Okay, you just consider only the poles and zeros on the real axis. So always consider P plus Z along the real axis only. Do not consider on the complex conjugate poles or complex conjugate zeros. Okay, so let's say how to find the part of root locus or not. So your real axis can be divided into different sections. Okay, so you just divide this real axis into different sections. So here, as we have one pole at -2, okay, so therefore I have considered this first section. So this is my section 1. Okay, so I have considered this section. Okay, so uh, I have considered the section along -2. Okay, so what is the addition of P plus Z in this section? So can you tell me what is the value of P plus Z in this section? ये सेक्शन के पहले P plus Z कितने हैं along the real axis? Can you tell me? कितने हैं एडिशन ऑफ P plus Z along this real axis? यहाँ पर सिंपली वन पोल है, so therefore P plus Z is 1, so therefore it is 1 है, that means it is odd. ये odd है, इसलिए odd है, that means it is a part of root locus. So therefore we just dark this section. Okay, so this section is a part of root locus. So that's why at the top of this dark line we just write down it is a part of root locus. So in this way we can identify a part of root locus. Okay, similarly abhi ye ho gaya first section. Then along the real axis we have another pole at -4, so I just consider that will be my second section. Okay, so here this will be my second section. I have drawn one line. Okay, so up to this section, for this second section, what is the value of P plus Z? Can you tell me? कितना है P plus Z along real axis? ये लाइन से पहले कितने P plus Z है?
2.
That is 2. This is 1 and this is second. So P plus Z is 2. So P plus Z 2 मतलब ये odd है या even है? It is even. Okay, so even रहा तो which is a part of non-root locus. So therefore ये जो भी section है इसके ऊपर हम लोग लिखेंगे NRL. So this is not a part of root locus. Okay, so ये section हो गया which is not a part of root locus. मतलब section कहाँ से कहाँ तक कंसीडर किया था हमने? -2 से -4 तक. तो -2 to -4 इसके बीच में रूट लोकस ब्रांचेस प्रेजेंट नहीं रहेगी. ओके, देन अभी -4 के आगे कोई पोल है क्या? अपना पोल या जीरो ऑन रियल एक्सिस नहीं है. ओके, सो देयरफॉर आई कैन कंसीडर द सेक्शन एट वर्चुअल इंफिनिटी. ओके, सो we just consider the another section at -infinity. Okay, so here is the line. Okay, so now for this section, can you tell me what is the value of P plus Z? ये section के पहले P plus Z कितना है? Calculate it along real axis. It is 3. This one pole, this is second pole, and this is third pole. So P plus Z is 3. So 3 क्या है? Odd. तो therefore ये जो भी सेक्शन है -4 से -infinity तक, इसको सबको हम लोग डार्क करेंगे. कंप्लीट लाइन हम लोग डार्क करेंगे एंड इसके ऊपर लिखेंगे इट इज अ पार्ट ऑफ रूट लोकस. Okay, so in this way you can find out the part of root locus and non-root locus along the real axis by dividing your real axis into different sections. Okay, and you have to apply this test P plus Z. So you have to count only poles and zeros along only real axis. Do not consider complex conjugate pair pole or complex conjugate pair of zeros. You have to consider only poles and zeros along only real axis. So this is the test for determining the existence of root locus on real axis. So this is your step number 3. So please note down this example and show the part of root locus and non-root locus. Do you have any doubt in the step number 3? Please understood these steps. और जो पोल के ऊपर हम लोग सेक्शन डिवाइड कर रहे हैं वो पोल छोड़ देना है while counting. Do not consider that pole. So write down step number 4. So our step number 4 is the number of asymptotes. Number of asymptotes. You have to find out the number of asymptotes. Okay, and generally when this number of asymptotes are present, so number of asymptotes are present only in case of when p greater than z. When this condition is arise, at that time only asymptotes are present. So we have already seen in the step number 2, when p greater than z, at that time p minus z branches are approaching to infinity. ओके सो जितनी ब्रांचेस इंफिनिटी को अप्रोच हो रही है so that much number of asymptotes are present. Okay, so what do you mean by asymptote? So asymptotes is nothing but it is a simply guideline for the branches to terminate on infinity is called as the asymptotes. Okay, so therefore write down the branches, write down the definition of the asymptote. The branches which are approaching, branches which are approaching, branches which are approaching to infinity, to infinity along a straight line, along a straight line are called as asymptotes. Are called as asymptotes, and asymptotes is nothing but the guideline for the branches. So these are the simply guidelines for the branches okay, so guidelines for the branches. Okay, then how to determine the angle of asymptotes? Okay, so therefore we have the empirical formula, that is theta. The angle of asymptotes are given. Theta is equal to, write down the formula, that is 2q plus 1 multiplied by 180 divided by p minus z, where this q is varies from 0 up to p minus z minus 1. So this is the expression for determining the angle of asymptote. So this theta indicates the angle of asymptote. 2q plus 1 into 180 divided by p minus z. So number of asymptotes always equal to p minus z. Okay. So their angles will be theta will be given by 2q plus 1 upon p minus z. So asymptotes is nothing but these are provided. So here as p minus z branches are approaching to infinity, तो कौन से एंगल से वो infinity के ऊपर approach होंगे? So that angle is nothing but the asymptote. So this is your step number 4, number of asymptotes and their angle. Okay, please note down this. Then write down step number 5. So next step number 5 is the centroid, determination of centroid, or which is also called as center of asymptote. Center of asymptote. So in the previous step we have seen the number of asymptotes and their respective angle. So where these asymptotes are meet together. Okay, so that point is called as the centroid. So centroid is nothing but it is the point where all the asymptotes are meeting together is called as the centroid. Okay, therefore you just write down the definition of centroid. Okay, all the asymptotes intersect the real axis at a common point is called centroid, and generally it is denoted by sigma. The representation for centroid, and how it can be determined? So the empirical formula for sigma, so it will be given by sigma is equal to the real part, summation of real part of the pole, summation of real part of poles minus summation of real part of zeros upon p minus z. So this is the expression. So in short, we just write down sigma is given by summation of real part of poles minus summation of real part of zeros upon p minus z. So this will give you sigma. Okay, and this sigma is always located on the real axis. So its location could be on either on centroid. So you just write down the properties of the centroid. So centroid is always real, is always real, and it may located on negative real axis or positive real axis, negative real or positive real axis, and another more property is that it may or may not be part of root locus. It may or may not be may not be a part of root locus. That means the meaning of this last statement is that this sigma value, it could be located either on root locus part or it could be located on the non root locus part. वो कहीं पर भी रह सकता है. Okay, so these are the few properties of your centroid. Okay, so this is our step number 5. Then we just go to step number 6. Please note down this. Write down the step number 6, which is very, very important. 6 and 7. So step number 6 is break away point. Break away point, or again step number 6 is break in point. So that we will see in next step. Point, or which is also called as breaking point. So everybody, please listen here. What is the meaning of breakaway point or breaking point? Okay. So I just give you a small example. Let's say this is our S plane. Okay. So one pole is located at origin and one pole is located at -2. Okay. Then third pole is located at say -4. Okay, so if you apply rule number 3 here, which section is a part of root locus and non-root locus, so you see here. So if you divide this into this section, so this section is a part of root locus. Therefore, we just dark this section. Okay, so this is the part of root locus. And then when you divide this section, so beyond this, T plus Z is 2. So therefore, this section is not a part of non-root locus. Okay, so after applying step number 3, we will get this information. Okay, so now where is the existence of your breaking point or break away point? So what do you mean by breaking point or break away point? So in the step 1, step 2, we have seen that root locus branches are always start at open loop poles and terminates at open loop zeros. Okay, and रूट लोकस ब्रांचेस ऑलवेज स्टार्ट एट k इज इक्वल टू 0. तो एक ब्रांच यहाँ से स्टार्ट होगा, एक ब्रांच ये पोल से स्टार्ट होगा एट k इज इक्वल टू 0. So when you vary the value of k is equal to 1, 2, 3, 0.1, 0.2, 0.3, like this. Okay, so root locus branches always follow the part of root locus. So your root locus may not travel in this direction because this section is a part of non-root locus. So therefore, your root locus, when you change the value of k to 0.1, your root locus may move in the direction of along the root locus, section of root locus. Okay, so for k is equal to 0.2, so your locus of the poles way increasing like this way. Okay, so in this way, as k value increases, the root locus are also. Okay, ये हो गया इसका ये पोल का रूट लोकस ब्रांच. Similarly, for this pole root locus branch may move along this as the k value increase from 0, 0.1, 0.2, 0.3, 0.4, 0.7 like this. एक पॉइंट यहाँ पर ऐसा रीच होगा कि दोनों ब्रांचेस यहाँ पर मीट टुगेदर रहेगी. ओके, सो दोनों पोल्स का रूट लोकस ब्रांचेस विल मीटिंग एट दिस पॉइंट. Okay, and this point is called as the breaking. This point is called as breaking point, or sometimes this point is also called as breakaway point. Breakaway point. Suppose at this point the value of k is 0.7. 0.7 को ये दोनों root locus branches are meeting at this point, but when the value of k exceed beyond 0.6, 0.7, so when k value is reached to 0.8, एक ब्रांच ये डायरेक्शन में मूव करेगी और सेकंड ब्रांच ये डायरेक्शन में मूव करेगी. Okay, so that's why beyond this breakaway point, the root locus branches are get isolated. So therefore, this point is called as breakaway point. So your root locus branches are moving away from each other. Okay, so this is called as breakaway point. Okay, so here is the existence of breakaway point. So you just note down breakaway point. Breakaway point is always exist in two open loop poles, consecutive open loop poles. Okay, so जहां पर भी ऐसे टू ओपन लूप कॉन्जिक्यूटिव पोल्स रहेंगे एंड वो दोनों में जो भी सेक्शन रहेगा, दैट सेक्शन इज अ पार्ट ऑफ root locus, then there is the existence of one breakaway point. Okay, so this is all about the breakaway point. So have you understood this? What do we mean by breakaway point? Okay, then how to determine the exact location of this breakaway point? अभी यहाँ पर हमने कंसीडर किया था कि 0.7 को ये दोनों ब्रांचेस यहाँ पर मीट हो रही है, तो ये पॉइंट कैसे डिटरमाइन करना है? तो फॉर दैट पर्पस स्मॉल टेस्ट विल बी देयर. So simply you just differentiate dk by ds is equal to 0. So you just equate this equation to 0, you will get the breakaway point. So I will give you the example in the next part. Okay, so this is all about breakaway point. So breakaway point is always related with the two open loop poles. Okay, and breakaway point always exists between the two open loop poles, which is a part of root locus. Then next step is the break in point. Next is the break in point. Okay, so this point is exactly opposite of break away point. Okay, so I just give you example of break in point. Where is the existence of this breaking point? So this is your sigma j omega axis. So let's say sometimes we know that, so we just take here, these are the two poles, and here we have two open loop zeros like this. So dot and circle, that indicates the notation for open loop zeros. तो यहाँ से आपका रूट लोकस ब्रांचेस स्टार्ट रहेगा, यहाँ पर आपका एक ब्रेक अवे पॉइंट रहेगा. ओके, देन एक ब्रांच इधर जाएगा, एक ब्रांच इधर जाएगा. ओके, सो वी नो दैट फ्रॉम स्टेप नंबर 2, root locus branch always originate at open loop poles and always terminates at open loop zeros. तो यहाँ से ये पोल का जो भी ब्रांच रहेगा, ये यहाँ से यहाँ तक आ जाएगा. ओके, और यहाँ पर आने के बाद में यहाँ से इधर ये पोल के ऊपर टर्मिनेट हो जाएगा, जीरो के ऊपर. सेम वे ये जो पोल की ब्रांच होगी, ये इधर से ऐसे आएगी और यहाँ से इसके ऊपर टर्मिनेट हो जाएगी. सो देयरफॉर दिस पॉइंट इज कॉल्ड एज द ब्रेक इन पॉइंट. सो यहाँ पर क्या हो रहा है, आपका रूट लोकस ब्रांचेस यहाँ पर इन हो रहे हैं. रूट लोकस ब्रांचेस आर इन हियर. So therefore this point is called as the break in point. So therefore this point is called break in point. Break in point. So here is the existence of this breaking point. So breaking points, you just note down, break in point is always exist between two open loop zeros. Two open loop zeros. And the section between two open loop zeros, section between two open loop zero, two open loop zero must be a part of root locus. Must be a part of root locus. Then and then the breaking point can exist. Okay, so you just remember here, breaking point is related with the open loop zeros and breakaway point is related with the open loop poles. Okay, then how to determine breaking point or breakaway point, so that we will see. So the small test we have to conduct, and we have to equate that dk by ds to be 0. Okay, so same test can be applicable to this breaking point also. Okay, so we just take down the example. So we have the characteristic equation given. So you just express your characteristic equation in terms of k. So k is a function of f of s. Okay, and from that expression you just determine dk by ds is equal to 0. Differentiate this equation with respect to s. Okay, so let's take an example. The characteristic equation is given by what? 1 plus g of s into h of s equal to 0. This is the generalized expression for characteristic equation. So let's say your g of s value is given to you. G of s into h of s is this value, k upon s into s plus 1 into s plus 4 equal to 0. Okay, so this is the characteristic equation given to you, and you have to find the breaking point or breakaway point for the given characteristic equation. So express your expression in terms of k. Okay, so if you expand this expression, here we are getting x cube plus 5s square plus 4s plus k is equal to 0. Okay, so here now you can express this k is a function of f of s. So here you are getting k is equal to minus of s cube plus 5s square plus 4s, and which is equal to 0. Sorry, it's not 0 here. Okay, so now you just differentiate this k with respect to s. So determine, obtain dk by ds, and which is equal to 0. So dk by ds, so differentiate this equation. So here you are getting minus of 3s square plus 10s plus 4, and which is equal to 0. So when you equated it to 0, okay, so find roots of this equation. So here you are getting 3s square plus 10s plus 4, which is equal to 0. So find the roots of this equation. So that will give you breakaway point or breaking point. Breakaway point or break in point. Please find it. So here you just apply that formula, minus b plus minus b square minus 4ac upon twice a. Okay, so you can apply those formula here. That is minus b plus minus square root of b square minus 4ac upon twice a. Okay, so you just substitute the value here. तो आएगा आपका -10 माइनस स्क्वायर रूट ऑफ b स्क्वायर इज 100 माइनस 4 into 3 upon 2 into 3. Okay, so if you determine this value, तो एक पॉइंट मिलेगा आपको -0.46 और सेकंड पॉइंट मिलेगा -2.86. So these are your 2 points, -0.46 and -2.86. ये मिलेंगे आपको ब्रेकिंग पॉइंट और ब्रेक अवे पॉइंट. तो इसमें से कौन सा पॉइंट वैलिड है, -0.46 है या -2.86 है? So that we will see while solving the example. So in this way you can find the value of breaking point or break away point. So in this way we can determine from the characteristic equation. So while determining the breakaway point or breaking point, you just remember dk by ds must be equal to 0. Okay, so please note down this. So this is our step number 6 or 7. So only 2 steps are remaining. To the step number 8. Angle of departure or angle of arrival. Angle of departure or angle of arrival. So this is your step number 8. Shall I rub this portion? So what is the meaning of angle of departure or angle of arrival? Okay, so you just note down the meaning. The angle of departure, angle of departure. So when this angle of departure or angle of arrival is present, the angle of departure is related with the complex conjugate poles, related with the complex conjugate poles. So when there is a presence of complex conjugate pole in your transfer function, then and then only angle of and angle of arrival angle of arrival is related with complex conjugate zeros. Complex conjugate zero. So please remember these two terms. Angle of arrival is related with angle of complex conjugate pole, and angle of arrival is related with complex conjugate zero. Angle of departure is related with complex conjugate poles. Then how to determine it? What are the formulas? We just note down, make the subsection in this. First we can determine angle of departure, at complex pole. Okay, so generally it is denoted by phi d. D stands for departure, and it will be given by 180 minus phi, where this phi will be given by summation of phi p minus summation of phi z. You just note down the meaning of what do you mean by summation of phi p or summation of phi z. So summation of phi p, while taking the example, it will clear to you how to determine phi p. So phi p is the combination of summation of phi p is the combination or the contribution by the angles made by remaining open loop poles at at which the phi d is to be calculated. While taking the example, it will be clear to you how to determine phi p. Okay, so the phi d will be given by 180 minus angle of this g of s into h of s. Similarly, for the summation of phi z, तो इंस्टेड ऑफ ओपन लूप पोल्स यहाँ पर सिंपली आप कर लो ओपन लूप जीरो. द रिमेनिंग स्टेटमेंट कुड बी जीरो. Same. Okay. Then second, angle of arrival for complex zero. Angle of arrival at complex zero. Okay, so it will be denoted by phi a. So it will be given by 180 plus angle of g of s into h of s, or it will be given by 180 plus phi, where this phi will be given by summation of phi p minus summation of phi z. So this is the formula for, and when this angle of arrival is present, when there is a presence of complex zero into your transfer function. Okay, so this is your step number 8. So in the actual, whenever you are solving the problem relating with the complex pole or complex zero, at that time how to determine phi d or phi a, so that we will see. Okay, so this is your step number 8. So this step number 8 is present only and only if there is a presence of complex pole or complex zero. So then and then only we have to determine phi d or angle of departure or angle of arrival. Then the last step, write down the last step, 9th step. Intersection of root locus with the imaginary axis. So step number 9 is the intersection of root locus with imaginary axis. Whether my screen is visible to everybody?
No, sir, it is paused.
Yes? Is it visible?
No, sir.
Okay. Once again I share it. So now is it visible?
Yes, sir. Yes, sir.
So give the last step, that is intersection of root locus with the imaginary axis. So अभी how to determine the intersection of your root locus branches with the imaginary axis, ये कैसे determine करना है? So for that purpose we have already seen the method, that is the root array method. Array method, we can determine the intersection of root locus branches with the imaginary axis. So whenever you want to determine intersection of root locus with imaginary axis, you have to use the method of root array. With the help of this root array method, we can determine the points at which your root locus branches are intersecting with imaginary. So note down the step. Okay, the value of k, अभी okay, again the point at which your root locus branches are intersecting to the imaginary axis, then the value of k corresponding to that point is called as the marginal value of k. Okay, so therefore write down the value of k, the value of k at which the root locus cross the imaginary axis, cross the imaginary axis is determined by roots criteria, and value of k corresponding to this point is called as k marginal. Value of k at which your root locus branches intersecting the imaginary axis, then corresponding value of k is called as marginal value of k. Okay, then how to determine it? So here we are going to apply a roots criteria. So just take similar example. We have characteristic equation 1 plus g of s into h of s equal to 0. So let's say g of s, h of s value, whatever we have considered previously. So k upon s into s plus 1 into s plus 4, which is equal to 0. So this is the value given. Okay, so find the characteristic equation. So if we expand this, it will give you s cube plus 5s square plus 4s plus k, which is equal to 0. Here we have expanded. Now apply the roots criteria. Solve this characteristic equation using roots criteria. Okay, so what is roots criteria? You have to prepare a root array. Okay, so highest power of s is s cube, s square, s1, s raised to 0. Okay, so which are the alternate coefficient? 1 then 4. So ये आ जाएगा 1 4 0. Prepare a root array. Then second आएगा 5k 0. Tell me the s1 row element and s0 row element. So 5 into 4, which is 20 minus k upon 5. ये आएगा आपका 5 into 0 1 into 0, ये 0 ही आ जाएगा. यहाँ पर आएगा 20 into this term, ये divided by that, so it could be simply k. Okay, then अभी for system to be stable, what is the assumption? रूट हार्वेस्ट क्राइटेरिया से स्टेबिलिटी कैसे डिटरमाइन की थी हमने? ऑल द एलिमेंट इन द फर्स्ट कॉलम ऑफ रूट हैव टू बी पॉजिटिव. तो पॉजिटिव होने के लिए हमें क्या कंसीडर करना पड़ेगा? this k value to be positive. Okay, so therefore here you will see this is the row corresponding to 0. Okay, so इसके previous वाला जो भी row रहेगा, this will be your auxiliary equation. You can consider this as auxiliary equation. Okay, and with the help of this auxiliary equation, okay, and from this equation आप पहले तो values determine कर लो. तो k value कैसी होनी चाहिए? Must be greater than 0. So for row corresponding to s raised to 0, from s raised to 0, so value of k must be greater than 0. तो row corresponding to s1 क्या मिलेगा आपको? s1 के corresponding भी हम लोग compare कर सकते हैं. 20 minus k upon 5 must be greater than 0. So from this expression determine the value of k. कितना आएगा k? तो 5 0 हो जाएगा, तो k इज इक्वल टू 20 मिल जाएगा आपको. ओके, सो k इज इक्वल टू 20. सो दिस इज योर मार्जिनल वैल्यू ऑफ k. So when k is equal to 20, your root locus branches are intersecting the imaginary axis. Okay, then determine the auxiliary equation. जो 0th रो है 20 माइनस k, इसके करस्पॉन्डिंग हमने k मार्जिनल बताया. ओके, सो s1 रो के करस्पॉन्डिंग हमें मिला k मार्जिनल. तो जो रो के करस्पॉन्डिंग आपको k मार्जिनल मिला, उसका अबव वाला जो रो है कंसीडर इट एज अ ऑक्सिलरी इक्वेशन. ओके, जिसके करस्पॉन्डिंग k मार्जिनल मिला, उसके अबव वाला रो यू कैन कंसीडर इट एज auxiliary equation. Okay, then what is your auxiliary equation? 5s square. So write down 5s square plus square के बाद में एक छोड़ दिया तो 5s square plus k which is equal to 0, and equate auxiliary equation to 0. Okay, so now substitute the value of k. 5s square plus the k value is 20, so 5s square 20 is equal to 0. Okay, then tell me the value of s. Tell me the value of roots of this equation. 5s square plus 20. कितने आएंगे? 5s square plus 20. Tell me the value of s. Roots of this equation. तो आपको मिल जाएगा s square is equal to -4. तो s is s square is equal to plus minus j2. So s is equal to plus minus j2. So that means at this value, at plus minus j2, your root locus branches are intersecting the imaginary axis. So in this way, you can determine the intersection of root locus branches with the imaginary axis with the help of root criteria. So please note down this example. So here we have finished with all the steps which are required while constructing a root locus. तो कल किसी का एक्स्ट्रा क्लास है क्या, अपार्ट फ्रॉम योर रेगुलर शेड्यूल? 10:30 to 12 कौन से सब्जेक्ट का है?
सर 9 से 10 सुबह जावड़ेकर मैम का है और 10:30 से 12 रेगुलर है, 12:30।
वो तो रेगुलर है। ओके, तो डेली रहता है मैम का?
नो सर, कल है बस।
कल है ना, फ्राइडे?
हाँ।
तो
नो
सैटरडे
सर,
को
सर
है क्या
सर
किसी का?
सैटरडे को है, सर सैटरडे को है, कल नहीं है।
अच्छा, कल नहीं है ना, तो फिर कल 9 से 10 ले लेते हैं हम लोग।
ओके सर।
सो वी आर गोइंग टू टेक द प्रॉब्लम्स बेस्ड ऑन रूट लोकस। एक सिंपल प्रॉब्लम ले लेंगे, फिर बाद में संडे को वगैरह ले लेंगे, फिर अपना यूनिट 4 खत्म हो जाएगा।
ओके सर।
Okay, so tomorrow at 9 a.m., 9 to 10 a.m., okay, we'll have a extra class. So we are going to solve problems based on root locus. Okay. Okay. Again, one more thing. Today I have uploaded 2 question paper on Teams. Okay. So आप कोई भी क्वेश्चन पेपर में का और कोई एक यूनिट के ऊपर एक क्वेश्चन लिखना है आपको असाइनमेंट के लिए, टीसी के लिए। ओके, सो सिंपली यू हैव टू राइट डाउन 6 क्वेश्चन। तो आपके पास में जो भी क्वेश्चन पेपर अवेलेबल रहेगा या कोई भी बुक होगा, ओके, तो बुक में से भी आपने लिए तो भी चलेगा, प्रॉब्लम्स या क्वेश्चन। तो सिंपली एक यूनिट के ऊपर ये क्वेश्चन आपको लिखना है। ओके, सो ऐसे 6 क्वेश्चन आपको असाइनमेंट में लिखना है एज अ टीसी। ठीक है, हर एक यूनिट के ऊपर एक कोई भी क्वेश्चन आना चाहिए, तो दैट चॉइस विल बी गिवन टू यू। ओके, सो ऐसे 6 क्वेश्चन लिख के उसके जो भी यू जस्ट स्कैन दो, स्कैन योर टीसी कॉपी एंड सेंड इट टू मी आइदर व्हाट्सएप और आइदर ईमेल। ओके, व्हाट इज कन्वीनियंट टू यू। ओके, तो आपको बिफोर 10th of December यू हैव टू सबमिट योर टीसी। ठीक है, अगर इसके अलावा किसी को कोई डाउट होगा तो आप पूछ सकते हैं। ठीक है, और टीसी आपको कंपलसरी सभी सब्जेक्ट के लिए एज अ असाइनमेंट ही सबमिट करना है। क्विज वगैरह क्योंकि अपने टेस्ट 1 टेस्ट 2 ये सब ऑब्जेक्टिव चल रहे हैं, इसलिए टीसी जो है वो असाइनमेंट कंसीडर किया है होल कॉलेज के लिए। ओके, so you have to submit your TC before 10th of December. ठीक है, और प्रैक्टिकल सबने लिख लिए। एक नोटबुक करो, उसमें सिर्फ एम ऑफ द एक्सपेरिमेंट, कंपोनेंट रिक्वायर्ड, सर्किट डायग्राम, ऑब्जर्वेशन टेबल और सैंपल कैलकुलेशन, बस इतना ही लिखना है। थ्योरी पार्ट नहीं लिखा तो भी चलेगा। ओके, उतना लिख लो। मैंने 2 प्रैक्टिकल्स के वीडियो ऑलरेडी आई हैव अपलोडेड, एक्सपेरिमेंट नंबर 2 एंड एक्सपेरिमेंट नंबर 4, और रिमेनिंग जो भी प्रैक्टिकल उसके वीडियो में ये 2 या 3 दिन में अपलोड कर दूंगा। तो उसमें सैंपल रीडिंग आपको गिवन है, तो वैसे ही सैंपल रीडिंग आप आपके ऑब्जर्वेशन टेबल में लिख दो एंड डू द सैंपल कैलकुलेशन। वो जो भी मैं वीडियो दूंगा उसमें कुछ कुछ प्रैक्टिकल के सैंपल कैलकुलेशन भी गिवन है, आप दूसरे रीडिंग्स के लिए ले सकते हैं या फिर वही लिखे तो भी चलेगा। Okay, so today we stop here. So we will meet tomorrow at 9 a.m. Okay, thank you.